Hello and welcome to Edu-Malanga. We do mathematics tutorials for Matric in South Africa. Today we're doing the last example on the sum of arithmetic series. In the next video we will introduce a new topic. The sum of arithmetic series is under the first unit of the year, which is patterns, sequences, and series. And the last example is going to be example 4. Example 4 is very different from the other examples that we have done, but once we work through it, I hope you'll find it easy and you'll be confident enough when you see it in your tests and in your exams. So example 4 goes like this. Given Sn is equal to 2n squared plus 4n. So we're given this, and because we're seeing Sn, we know that this is the sum of arithmetic series question, and we're going to answer two questions to do with this arithmetic series. The first question we will answer, 1, is find the first 4 terms. So we need to find the first 4 terms of the arithmetic series. So we've been given that Sn, the sum to the nth term, is equal to 2n squared plus 4n. This is highly unusual because you're not seeing a or d or any of that stuff, but it is actually very easy to solve once you get started. Let's get into it. If we recall, for an arithmetic series, what you happen to have is you have a plus, and then you have a plus d, which is your next term, plus a plus 2d, and that's the next term, and your terms keep on going. And the only difference between the arithmetic series and the arithmetic sequence is that when you have a sequence, you don't add the terms, but when you have an arithmetic series, you start to add the terms. So in this question, we were given Sn, which is an arithmetic series, so we're going to use our understanding of the sum of arithmetic series to solve. Let's get started. If you have to sum up the terms of an arithmetic series and we say to you s to 1, what is that equal to? It's the sum of the first term, and essentially, it'll only be the first term. So that's easy enough to solve. We can then do this for the arithmetic series we're given here. Let's get started with it. You have Sn is equal to, we'll just rewrite it on the page, 2n squared plus 4n. 2n squared plus 4n. So if you do S1 for this series, you're going to have 2 times 1 squared plus 4 times 1. And that's equal to, 1 squared is equal to 1, so you have 2 plus 4 times 1 is equal to 4 as well, 4, which is equal to 6. So the first term of the arithmetic series, let me write my answer on the same page as the question, is equal to 6. The term that will follow now is going to be term number 2. So term number 2 is going to be S2 now. And that's going to equal to 2 times 2 squared plus 4 times 2. What we've done, because we're looking for the second term, is we've substituted everywhere we are seeing n, we've put the number 2. This is then going to equal to 2 squared is equal to 4, so you will have 2 times 4 plus 4 times 2 is equal to 8, so we can simplify that. 2 times 4 is equal to 8 as well, so you have 8 plus 8, and that's equal to 16. Now let's come back to what we did here. The sum of the first term is simply equal to the first term, and the sum of the first 2 terms is equal to the first term plus the second term. So if we're looking for the second term from the sum of the 2 terms, we have to subtract the first term. I hope what I'm saying makes sense. Let me write it down and explain using the variables. You have s to 2 is equal to a plus d. This is term number 1 and this is term number 2. So if you're looking for term number 2 then, term number 2, which is a plus d, is going to equal to s2 minus a. If you weren't able to follow earlier, I hope you now understand. So to find term 2, we're going to have S2 minus A, which is going to equal to 16 because we solved for S2 as 16, and our A on this page we found to be equal to 6. 16 minus 6, which is going to equal to 10. So that's going to be our second term of the arithmetic series. 6 plus 10. We have to find 4 terms, so let's do this again for term number 3. We're going to have S3 is equal to 2 times 3 squared plus 4 times 3. Everywhere where we had the variable n in the equation, we've substituted the number 3, and that's going to equal to 3 squared is equal to 9, so we'll have 2 times 9 plus 4 times 3 is 4, 8, 12. So we're going to have in the end 2 times 9, that's equal to 18 plus 12. 18 plus 12. The 8 plus the 2 gives you a rounded 0, and you'll add 1 to what you have, 1 plus 1, so that's equal to 30. Again, for you to find term number 3, you're going to have S to 3 minus S to 2. You're going to have to subtract what you've just calculated over here with the sum of the first 2 terms, and the difference is going to be the third term. So term number 3 is then going to equal to 30 minus 16, because our S2 we solved for as 16, and that's equal to the number 14. If we come back to this page, it's plus 14. To find the fourth term, we're not going to bother ourselves doing this long method. We're going to do a quick cheat by looking for the common difference, because remember, when you have the sum of arithmetic series, what you have is an arithmetic sequence, but instead you are adding the terms, so you will still have a common difference. What's the common difference between these terms? We use this term and we subtract that term to find the common difference. So we'll have 10 minus 6, and the common difference is equal to 4. Okay, then you say 14 minus 10, again the common difference is equal to 4. And lastly, then we will find the fourth term by saying 14 plus the number 4 to give us the number 18. And these are the first 4 terms of the arithmetic series that we have been given over here. I hope you understood and were able to follow. The second question we will answer for this arithmetic series is find term number 8 using the equation Sn is equal to 2n squared plus 4n. So you know the first 4 terms of this arithmetic series, and you've now been asked to find term number 8. Let's come back to what we did here. Remember how we found term number 3? We found the sum of the first 3 terms, and we had the sum of the first 2 terms, and the difference between those two was equal to term number 3. So to answer this question, we can say that T8 is equal to the sum of the first 8 terms minus the sum of the first 7 terms, and what remains is going to be our 8th term. So let's start by solving for the sum of the first 8 terms. We're going to have S8 is equal to 2 times 8 squared. We're going to substitute 8 where we're seeing n, plus 4 times 8. You'll have to use your calculator for this one. Is equal to 8 squared is equal to 64. So we're going to have 2 times 64 plus 4 times 8, that's equal to 32. And we'll then have 2 times 64 is 128 plus 32, and that's equal to 160. We've now found the sum of the first 8 terms. Let's find the sum of the first 7 terms. S7 is going to equal to 2 times 7 squared plus 4 times 7. That's equal to, 7 squared is equal to 49, so you'll have 2 times 49 plus 4 times 7, that's equal to 28. And 2 times 49 is equal to 98 plus 28, and that's equal to 126. So to find the 8th term, T8, we're going to say it's equal to 160 minus 126, 160 minus 126, and that's equal to 34. So the answer to the second question that we were asked to find term number 8 is that T8 is equal to 34. This is the end of this example. I hope you were able to understand what we did and you were able to follow. Join us again in the next video. We will be introducing a new lesson, which is the sum of geometric series.